This was the route for the water, through the core of the mountains, through 13 miles of granite, through 50 years of dreaming, 7 years of making. A straight circular tunnel under the mountain barrier, the key feature of a complex water system. It took experts to plan and build this system. Let's hear one of them describe it.
Most complex engineering enterprises, the Colorado Big Thompson project. The CBT covers a lot of ground, 3,000 feet up and down and 100 miles across. A clever and complicated system that can make water do just about everything, even flow uphill. In 1820, Major Long, commanding a government exploring expedition, pushed along the trails into the wilderness west of the Mississippi. He didn't think much of the land now served by the CBT. In fact, he said the place was almost wholly unfit for cultivation. We'll soon see how wrong the Major was. Now, let's go over the 14,000-foot Continental Divide to the west slope. Here, the water is collected and stored, later to flow to the farmlands east of the mountains through the Adams Tunnel. But before these reservoirs could be built, the people on the west slope had to be sure that their water rights wouldn't be damaged. 40 miles to the southwest, the eastern slope interests created a reservoir where the Blue River flows past Green Mountain to the Colorado River. The Blue carries surplus water, the east slope people pointed out. We'll save this surplus and, in effect, substitute it for the other water we'll divert through the tunnel. What's more, we'll pay for the whole thing. The idea made sense of getting a steady flow for rich western orchards, and an agreement was reached. Thus, Green Mountain Dam was built before any other project featured. Now, the reclamation engineers were ready to build the reservoirs for east slope irrigation water. They chose an area northeast of Green Mountain, near Grand Lake. This location, the source of the Colorado River, is at the base of the Continental Divide. Drill a 13-mile tunnel under the divide, the engineers said, and take the water to the thirsty farmlands on the other side. It was agreed that the level of the lake had to be kept stable. To do this, the Colorado was dammed, and Shadow Mountain Reservoir formed. Its water surface the same as Grand Lake. To make the plan work, another major reservoir was now needed. Below Shadow Mountain was a great natural basin shaped in ages past. The engineers formed the dam and dikes with 5 million cubic yards of earth and rocks to create the main storage area of the system, Granby Reservoir. Another source of water for Granby was Willow Creek, a tributary of the Colorado. A dam was constructed and the collected water could now be run into Granby and stored. But there was a problem. Willow Creek Reservoir was 170 feet lower than Granby. Solution? A pumping plant to lift the water from the reservoir and pour it into Granby. The stored water must again be lifted, nearly 200 feet this time, to Shadow Mountain Lake. This is the job of the gigantic heart of the system, a pumping plant equal in height to a sixth by the Bureau of Reclamation, is submerged in the shore of the reservoir. 3 7-foot conduits carry the water from the bottom of the reservoir through the pumps into an 11-foot concrete pipe up to the canal that feeds Shadow Mountain. A 6,000 horsepower motor turns each of the 3 vertical shaft pumps. Together, the pumps can lift 500,000 gallons a minute to Shadow Mountain Lake. Enough water in 1 minute to supply a person's needs for 10 years. So this is the water collection system for the project. Runoff water into Shadow Mountain and down into Granby. From Willow Creek up into Granby. Stored water from Granby into Shadow Mountain to flow across Grand Lake and through the Adams Tunnel to the East Slope. In the average year, 400 million tons of water flow through the East Slope system. The water drops 2,800 feet from the east portal of the Adams Tunnel to Flatiron to be pumped into Carter Lake, or flows along the Hanson Feeder Canal across the Big Thompson River and into Horsetooth. The east portal is at the top of this system. As much as 1,000 tons of water a minute sweep out of the Adams Tunnel into a small lake that regulates the outflow. From here, the water travels underground some 2 miles to Mary's Lake, then down pipes called penstocks, each 4,000 feet long, to Lake Estes. The reservoir is created by Olympus Dam across the Big Thompson River. The location of this feature gives the project half its name, the Colorado Big Thompson. From Lake Estes, the water travels 13 miles and drops 1,000 feet into Rattlesnake Reservoir. Then down the penstocks another 1,000 feet into Flatiron. A pump lifts the water 240 feet up through a pressure tunnel into the first major eastern reservoir, Carter Lake. The flow in the tunnel can be reversed if desired, and water returned to Flatiron Reservoir. From here, the water flows by gravity along the Charles Hanson Feeder Canal, across the Big Thompson River in a siphon, and on to Horsetooth. This reservoir, created between 2 hogback ridges, is the largest on the east slope. Remember, this water has dropped half a mile. The water force developed is made to turn giant hydraulic turbines that revolve generators and produce electricity. In fact, the sale of this electricity will pay 80% the entire project construction cost. There are 6 power plants in the project. Green Mountain on the west slope, and on the east, Mary's Lake, Estes, Pole Hill, Flatiron, and Big Thompson. The Green Mountain plant is located at the toe of the dam. Water is released downstream throughout the year, so one or both of its units can be operated continuously. Heavy steel penstocks embedded in the dam carry the water to the turbines. On the east slope, project water is first used to produce electricity at Mary's Lake. On rare occasions, the power plant can be bypassed and the water sent directly into the reservoir. Mary's Lake provides storage for the operation of the Estes plant. The capacity of the 3 generators makes Estes the second largest plant in the system. Each generator is driven by a 21,000 horsepower turbine. A main feature of each turbine is a huge water wheel weighing 4 tons. The water, under tremendous pressure, gushes through the turbine and pushes these steel scoops as it passes. The wheel is mounted flat. The shaft runs straight up to the generator. From Estes, the water drops 800 feet to the Pole Hill power plant. The single generator is unattended and is remotely controlled from the Flatiron plant. The semi-outdoor design of Flatiron is deceptive. Actually, this plant is the largest in the system. The three generators produce 60% more power than Estes. One of these units also can be operated as the pump that lifts water into Carter Lake. Any system as complex as the CBT must have a brain. This brain is the dispatching office, located in the Flatiron area. Here are received the orders for water deliveries and power demands. The dispatching center controls not one, but three power systems: the Colorado Big Thompson, the Big Horn, and the North Platte systems in Wyoming. Information is fed back from all operating units and directions sent to the plants for appropriate action.